How do we add a warm-up period to our SimPy model? To answer that question, we briefly need to review what is a warm-up period and why do some models require them. In the real world, many systems that we model have no natural ending point. For example, if we were modeling waiting times for a cancer screening service, there's no obvious point where we should terminate the model. The other thing about those systems is that the performance of them tends to vary around what we call a steady state. But at the start of the simulation run, there's this period that we call the initial transient. That's what we can see depicted in this chart here between 0 and 150 observations of the mean waiting time. And this part of the model output looks very different from the data after 150 observations. And the reason for that is that our simulation model starts from empty, and we get this bias in the initial transient that's really nothing to do with how the real system is performing. And one way to deal with that is what we call a warm-up period. So we split our results collection into a warm-up period and a results collection or data collection period. I'll illustrate how a warm-up period works with this really simple model of an acute stroke pathway. In this model, stroke patients are going to arrive following an exponential distribution. They'll queue up for acute treatment. They'll seize an acute bed. Once acute treatment is complete, they'll release that resource. Let's perform a single run of that acute stroke pathway model. We'll print out debug information and we'll set up a default experiment. We're going to run the simulation model for a total of 6 days. That's a warm-up period of 0 days plus a results collection period of 6 days. So we can see that a total of 5 patients have arrived to the model and they've all been admitted immediately. If we take a closer look at the results that have been collected, you can see that we've logged there's been 5 arrivals to the model and that each of their waiting times has been 0. Let's change the parameters of the model so that we now include a warm-up period. We'll again run the model for a total of 6 days, but at the end of the 5th day, our warm-up period will complete, and then we'll only collect results for a further 1 day. So we can see here that 2 patients have arrived to the system, and then our warm-up period has completed, and then there was a further 3 patients that have arrived to the system. If we have a look at results, we can see that we've only logged 3 patients that have arrived and 3 waiting times for the acute ward resource. The reason for this is that a warm-up period resets results when it occurs. It turns out that implementing a warm-up period can be very, very simple. We're going to implement it as a single event that occurs once within the simulation run. So I've defined a SimPy generator function called warm-up complete. Into that, I'm passing a float value called warm-up period. That's how long the warm-up period is going to last. A SimPy environment and a custom object of type experiment, and that contains all of the simulation parameters as well as a method for resetting the results during a simulation run. We yield a SimPy timeout equal to the warm-up period's length. I've got an optional bit of debug information here that prints out the warm-up period is complete, and then using my experiment object, I reset all of the results variables that I'm collecting. Let's take a quick look at the experiment class that we used to reset the simulation results. Now it's up to you how you set up your results collection in your simulation model. I tend to create a class called experiment that manages my parameters for the model, my random number streams, and the results that I'm interested in collecting. And it contains a method called init results variables. That creates a results dictionary called results, and within it, it creates 2 keys. The first is n_arrivals, and that's just going to be an integer value that counts how many stroke patients have arrived. And secondly, I have a key called waiting acute, and that's a Python list. And in that, I'm going to log the waiting time of every patient who has waited for an acute stroke bed. Lastly, the single run function does need to have some information about the warm-up period. So we're going to pass in a parameter representing how long that warm-up period will last and how long the results collection period will be. And within the single run function, we schedule the warm-up period to complete. So we called ours warm-up complete, and it accepted the warm-up period, a SimPy environment, and an instance of the experiment class. We passed that generator to the SimPy process method, and that's now scheduled to complete after however many time units we've included. And then we run our simulation model for the warm-up period plus the results collection period. And at the end of the run, we calculate our simulation statistics and return those to the calling code. All of the warm-up code is available on GitHub. I'll link to that in the description below. And if you're finding today's video useful, please hit that like button and subscribe to the channel. If you want to see a warm-up period implemented in a more complex model, then check out this video on the screen now. And I'll see you next time.